So yesterday we kind of got into part C where we talked about how arrays and memory works. And I introduced you the concept of a pointer, um, and then structures that use a new keyword are basically the variables of those types are pointing to locations in memory, which gives you access to the data that you're trying to access. Because they're complicated structures, so they place it in a special portion of memory called the heap, um, which is still very quick to access, but not as quick as the other portion of memory, which we call the stack, which kind of places things on top of each other as they're being executed, and all the primitive data types, things like that, usually typically get put on that stack and are very easy, or sorry, very fast to access. Okay, and there's other features of the stack. This kind of first in, last out kind of ability or property of it will allow us to do things such as recursion, which we'll get into when we talk about more advanced data structures later on in the course. So keep the stack kind of in the back of your mind how that works, because that's going to help you a little bit later on. Okay, for now, just know that whenever you run a method or code inside a button, all that code just kind of gets thrown on that stack. Once it's done, everything is deleted off of it. Okay, and in order to remove memory for one of those structures that use the new keyword, in higher level languages such as C#, we don't have to explicitly state that we're removing them from memory. There's a system called the garbage collector, which actually goes in and deletes it for us. Whereas other languages such as C or C++ that utilize pointers, you actually have to go into the you actually have to specifically or explicitly state the removal of those structures from memory yourself. Okay, so that's kind of what we talked about. It is kind of complex stuff, so do listen to the video a second time if you need to. And then what we did is we proved that how those variables work, arrays work. So if we create an array, then we create a second variable, but we don't use the new keyword and just set it equal to the other another array. Then we prove by testing out ourselves that they're both pointing to the same location in memory. You change one of the elements in one of those arrays, point to the same thing, you're changing it in the other. We looked at that yesterday, right? Did you guys do a copy? Create two copies? Did we do a copy yet? No. We didn't do that. Okay. So did most of you were able to get to the point where you created an array and then you created a second array with the new keyword, just set it equal to it, right? And we saw that. So I don't know what you want the screen thing here. I thought it was just for period one. Okay, I'll send that. Let me just write that in. I think that's what she said. I didn't quite hear her. I don't really want anyone to miss anything I'm talking about, so hold on, we'll send it down later. Too bad. So what I want to do today is, if you want to have two variables or two arrays, and you want one to be an exact duplicate of the other, you can't just do it in the method that we did yesterday, right? Because if we use the method that we did yesterday, you're making them point in the same location. Okay, so let me just put those on the board. Sorry, I should have had this up already. Forgot to put it up. So if I created an array and I wanted a second one to be a copy of it, I said, well, one way, if we do this, right, we looked at that yesterday. If we do that, the variable y is pointing to the same location of memory as the variable x is, right? That's what we talked about yesterday. So if I change one of the elements in y, it's changing the same corresponding element in x. I didn't create a copy. I just created a variable that points to the same part in memory. So that doesn't, this does not copy. Okay? Think about the bugs that you can create in the program if you think the two are separate and independent of each other, right? Right? Huge. So what we want to do is create a copy. So if I want to create a copy, you have to manually take every element from the one array and copy the value portion of it, not the array portion of it, right? Copy each individual element. So if you want the first element, which is index 0, to be the same in x and be the same in y, you have to copy element 0 in x to y. And you do that for every single element. So in order to copy every single element in one and the other, you got to make sure that both the arrays are the same what? Length, right? And then you're going to use what type of structure to copy one into the other? How am I going to iterate through or go through every single value? What do you use? What structure makes me go? Can I easily do that with? Yeah, for loop. So you're going to use a for loop. So for loop, right? And for. I'm kind of writing everything in kind of, this is like pseudocode. I'm not writing all the code in C# for you explicitly because I kind of want you to do it. So I kind of write it in kind of pseudocode, right? It's not complete code yet, C#. So for the for loop, so you're going to loop the length. So let's say we want, so you're going to set x and y to same length. Or you're going to set, y to same length as x. Okay? Take that out, right? So let's say you create, so you're going to create a little test program. You can put another button on the program that you were just doing, and you call it copy array. So create the array called x, which you could copy over from what you did in the last program, right? From yesterday. You must initialize some array with all values, right? So copy and paste that code over. Instead of a different button, you can use it, right? And then create another variable. I'm just calling them x and y here. You can use whatever names you like, array 1, array 2, whatever. Okay. Then create a second array, but make sure you use the new keyword this time, and make sure you set it to the same length as the array you're going to copy from. And then you're going to create a loop. So you're going to loop the length of x or y, because they both should be the same length. Right? I would use x. And then you're going to assign each value in x to corresponding value in y. So it looks something like this. yi equals what? If I'm using I as my counter, x, I. Make sure you don't just say x, you gotta say xi. Yi equals xi. Right? So as I loop through, when I is 0, it's going to be x0, it's going to, y0 is going to be x0. And then it copies the value from the one into the other. Copies the value from one to the other. Because I'm pointing to a primitive data type, so now I can copy them over. So my x structure, so if here's my x is pointing to here, my y is pointing to here. And as I run this, it'll take the values, sorry, this thing's off a little bit. It'll take the value from here and store it in here. It'll take the value in here and copy it in there, right? So then y, all the values inside y once this for loop is done, we'll have everything, and it points to its own structure in memory. And now I have two complete copies. So now I could go ahead and change whatever I do to X will not change any of the values in Y after this point. I make any changes to Y to any of the values inside there. It's a completely separate structure, so there's no connection to the other one. Okay. When we use the equal sign for and we're using like basically using the equal sign with primitive data type, we'll copy from one to the other. They copy. But when we use the equal sign and they're just the objects, then they point to each other. So that's the only difference. So that's why that pointer stuff we did yesterday was good to know. So you don't fall into that caveat, which is very common in bugs quite often. And the other thing I want you to look at is to resize an array. So if I have an array that has 3 elements, so let's say it's X, what if I want to delete one of the values inside here? Let's say I want to delete this one. Right? So my new array should be correct? How do I do that? No Saxons. You just use with me. So what would you do? Okay, I know which element I want to delete. Right? So if someone said, I have this element, and then you have everything stored in this array, and they're showing it on the screen, and they want to delete one. Right? How are you going to do it? Brainstorm. Come on, let's think. What do you think we're going to do? Well, X is going to change stuff. X has to change size now, doesn't it? Right? Yeah, the answer is think. Don't look at the notes. Okay. Okay. So in order to do this, you want to create there's a couple of different ways to do it. Okay. But I kind of want you guys to think about how to do it. You guys have to look. Think. Think how you would do it. You can look up stuff, but it's good if you can come up with it on your own. Brainstorm. Don't look at the sheet. Take a couple of minutes amongst yourself. Come up with a solution. Let's go. I'll give you guys 5 minutes. Come up with a solution. How are you going to do it? Don't look at the notes. You're cheating. Huh? No. Just brainstorm together in a group of 2 or 3 or 4 of you and come up with a way how you would do this. Okay? Work together. You're on a job. Someone said, we got a list of things in an array, and we got to delete one. How are we going to do it? You're sitting there, and you're like, okay, you're going to work with other people and figure out how you're going to do it. Don't look at the notes. Just think about how you would do it. Take into account. I'll give you one little hint. You gotta do something with the copy, right? It's the only way. Huh?
Copy X, and then hardcode it.
Because you have to create an array of these size. You don't want to use the same variable name. If I have an array X already exists, if I say X equals new and change it to the size of 3 now, everything that was in it is gone.
So you know how we did Y create a new
Yeah, keep going.
Y equals X bracket I.
No, if you do Y Yeah, you want to copy every element. So you're gonna do a copy into to a temporary variable like y.
And then hardcode it and tell it that it index 2 if you don't display that variable. Just display the rest of
When you're copying them into it, you have to have an if statement or something, and skip over the one you don't want. Oh, someone just run this down real quick.
just copy and if statement and tell it when it goes to the second one, right? Skip not to add it. Trying to explain it differently. Yeah, I don't know if it's exactly.
This new people realize that Nashi dies in my makeup. Nashi just dies in makeup. She's not understanding that. Nashi dies. Nashi dies. You got it?
Okay. Any ideas except Brian? Or did you tell everybody? Because he read it. No. He read it, so if I create a variable, so x, so I have to, so if I want x to be of a different size, as soon as I use the new keyword with it, right? So if under here I just say x equals new int 3, what happens to all the values in the structure? They go away. Well, now it's actually created, it's pointing to a new location of memory that only has 3. But I don't have reference to the other one anymore. It's gone. Okay? So as soon as I do this, the problem, so before I do this and resize it to a smaller size, because in this case I'm saying delete one, what I can do is I can create a variable, maybe let's say called temp. There's other ways of doing it. I can't remember which way I said in the notes, to be honest with you. So temp as a copy of x. So now temp has it has all the values that x is, 3, 7, 8, 9 in it, right? So you wrote the code to make a copy, right? Then what I do is I resize x. So this is resizing x. Then all I have to do is what? Well, if temp is now has this data in it and I want this data in it, so what am I going to do? How am I going to get the values from? I got to copy the values from temp into x, right? So I'm going to do what to do that? How am I going to do that? If statement and. So I have to leave one of the ones out, right? The one I want to leave out this one. So, but the main structure I got to go through is what? For loop. So I got to write a for loop to go through every one of these, except when I hit index 0, 1, 2, I got to skip over it, right? So I got to loop through So I'm going to loop through temp, and then I'm going to have an if statement, if, and then I'm going to skip the index that is to be deleted. Oh, that is. Okay. Then at the end, X now. So I'll write a loop. So I'm going to loop through here. I'm going to loop. The 3 is going to come. The 7 is going to come. And then I'm going to say, oh, the if part's going to hit if X equals 2. Don't copy it over. Right? Or I might have an if statement in there that says if I is not equal to 2, then just copy. And then when it comes to I equals 2, it'll skip over. Right? So then you'll know. If I create another variable, it might work. I'm going to test it out. If I create a variable and I say temp equals x, instead of making a copy, this temp will point to this structured memory. And then if I set x equals to new, I still think temp will still point to the other one. I'm going to try it out. See, I can't remember how I did it in the notes. Did I do it that way or did I do it this copy way? Copy way? Yeah, I'm gonna try doing it the other way. Because the way things work, I usually don't explain it this way. As long as there's a variable pointing to a location in memory, even if I got rid of the x, I deleted it somehow, but there's still one pointing to it, it won't delete that thing in memory. But that may be something I shouldn't show you guys. It might confuse you. It's just taking things like, yeah, you know what, just do it this way. It's the safest way of doing it. Okay, the other way it probably work, but it's just getting confusing. Okay, so you're playing around with copying, right? So I have my original set of data, and I want to delete one of the elements inside, right? So I know which element I want to delete because my program let me indicate. So I make a copy of that original data, and then I resize the existing array. So now it's all reset to zeros, right? We're dealing with numbers. And then I just do a loop to copy over all the elements I'm supposed to copy over, and I just skip over the one I did not want. It's done. Okay. If I want to increase the size, all you have to do is copy to the other one, but then just leave the other. So create a copy of the original, right? Do the same thing. Create a copy of the original, right? And then resize the original array. So now it's bigger. But then all you got to do is copy everything from the array the temporary array into everything. It'll just copy it. But then the extra spaces that were there, because it's bigger now, will just be whatever default of 0, or if it's numerical that we're dealing with. And you just do it that way. And then you can insert in the extra values. Okay. So it's not hard to do, you just have to try it. I think I even have the code in there, don't I? Pretty much the code's there in the notes. So what I want you to do is you can add a button. I want you to write a resize array where you want to delete one of the elements. You can hard code that in what element you want to delete. So you can typically your program would have some sort of interface. The person might click, I want to delete this one, and then say save. I mean, we don't want to get it that complex. We just want to test out how to resize an array by removing one of the elements inside of it, right? So you can simulate that by having a variable that tells you what the person already clicked on, like what index. So you make up your own index. So make your array whatever size, initial array. Create a variable that says that stores the value of which element you want to remove, and then resize it with that one knob. If you want to run it again with a different variable or a different index that you want to remove, then just change the index value. Make sense? You guys understand? Follow me? What you actually do? Okay. You would probably have a user interface that would do it because it would be interactive. But you're not doing it that way. You're coding it inside your head. You know what I mean? You're simulating that part. Okay. Also, what if you wanted to insert and make insert a value, and it would just be inserting it at the end. Okay, we're just going to do resize and then put it at the end. Forget about somewhere else. Okay, just at the end of the array. So what you do is you create another button that does that, and then you'll just say what the extra value is, put whatever number it is, store that in a separate variable. You're going to simulate the person saying, oh, you know, going into the user interface and saying, I want to insert a value at the end of this file, which is stored in the array internally. And then when they hit save, right, you don't want to have to write all that code, but you can simulate it. Okay? You just store it in a variable. I think you guys need a couple days to do this. We'll take this. Okay? You need to absorb, you need to start to learn how to test things out on your own without writing the full program to understand concepts. Right? Does everyone understand what to do? And then just insert at the end. Right? Then we can think about inserting it in different ways. What if I wanted to insert a value, you know, between here and here? It's not that hard to do. Just when you're copying it, instead of copying everything over and then putting it at the end, you copy and you have the if statement inside your for loop, so when you hit that index, you put it in there, and the other ones, well, you might have to do a little more than that, but something like that. So that would be good to do. So let's start with this. Midway through class tomorrow, we'll do the resize with the leading one. And I'll do that with you. And then we'll start working on the resize by adding one at the end of the array. Then we'll see how we're doing, and we'll think about if we do one where we can insert it anywhere inside. Right? You can cut and paste probably the code that you did already, and just modify it real quick and make it work for that. But we got to get these underhand. Yes, you've never done it before. Yes, you're probably like, oh my God. When you start doing it, it's not that bad. Just think, read the notes, you'll be able to do it. I get these looks, even last year and the year before. I get it every time because it's different and it challenges you now. You actually have to think. It's not a program where it's so easy, just type in the formula and it runs. It's all good. No, now this is what computer science really is. Right? Okay. So now you get to see what it's all about. Okay. So you guys can do it. Don't be afraid. Just try it. Get those quirky little smiles. You can do it. One step at a time. Yes, you can. I want to see who the first one is. I think I even wrote most of the code. So you're pretty good. Most of the code's already written for you.
Okay.